So, welcome to session 13 of designing a traditional Irish flute in Fusion 360. What we're going to deal with in this section is the foot joint, which is the last physical piece of the flute. You'll see that we're looking at a finished version of it here. You can see we have the two reinforcing rings, one at the top, one at the bottom. And we have the timber body, and we have two vent holes. Now these are not tone holes. They are designed to actually acoustically truncate the flute and engage at the inner bore of the flute, engage with the outer atmosphere. Now this isn't just a simple piece of turning. There are three tapers involved here. You have the external taper on the timber, which is a matter of taste and, if you like, conformity or fit with the taper on the upper and lower middle joints and the overall shape of the flute. So that's an aesthetic matter, as well as determining what the end weight of the entire barrel is. The entire flute body is. But we are also looking at two internal bores. I think this is this one. No, let's see, I'll chase it down here in the history. So we have the first bore. This is the what I call the forward bore, or the down tube bore, and it's the 1/60 bore that we've pursued through the lower middle joint, the upper middle joint, and it's an integral part of the pitching, the proper voicing of the flute. So we have to get that right, and it's going in the direction this way, which is forward. But we have another one. There we have it. And in some instances, makers use what I call a reverse taper of 1/60, which is a widening of this end here, usually with the same reamer that is used for the forward taper, to reverse taper bore up, but only up as far as the lower vent hole. You can see it actually goes, this one actually goes, I think, just short of or to the middle of the lower vent hole. While, where did it go? This one meets it exactly at the middle of the lower vent hole. Okay, so it's a complicated little piece to design. So with that in mind, I'll close that down. So we have here a new design, so go to File, New Design, and File, Save as Flute Foot Joint. And the first thing we'll do is we'll create our new component. And we'll call it Timber Body. And in the timber body, we want to go to the origin, pick up the YZ plane, and we'll create a sketch, circle, and that one needs to be 24. Finish sketch. Now we need to construct the other end of the foot joint, and we do that with an offset plane. Construct offset plane, and we want to go from here, and that value has to be 145. And we construct another circle on that one. That needs to be 22.5. Finish sketch. So now we have two circles existing in space, and we have to create the body between them, and we'll do that using Create Loft. There it goes. So we hit OK and we have the solid body. Now you can modify the physical material to your taste. I'm going to leave it the way it is for the moment. And what we're going to do now is we're going to deal with the shoulders to seat the reinforcing rings. Now while we'll do this in the actual design, these shoulders would be one of the last things you would actually put in place when you would be making you're turning down the foot joint yourself. So we need to create two drawings. The first one is a circle here. And that is 21.5. Now, to allow me to make the cut, I need a cylinder to cut, so I'll do something like 30. Finish sketch. Let's have a look at it. And we want to remember, you have to select the two profiles. We want to send it into the body. We want it to go -4 for this design. So there's one shoulder. Go home. Now we want to go here. And we'll put a circle here. C for circle. And this one needs to be 23. Another circle. I get that 30 again. And finish the sketch. And we will cut. Take the two profiles. Go -4. Look at it. Have a look at it square on. Two shoulders are looking good. Now at this stage in the design, I would typically, before I start boring or putting in tapers, I'm going to create a drawing because I need to check the internal dimensions of anything I do on the inside. So we'll go and we'll create a drawing. File new. From design. Now what I have there is I have a template I made previously. It's a simple template just to capture some basic information to include in the drawing. And we want to show it as 1:1. So I went up here to pick up the base view, clicked on it and put it in. And what I want to do is show visible and hidden edges. So all we have is a solid body, so there are no hidden internal edges to be seen. But let's just check now the dimensions, make sure that we have, yes, 23, 21.5, and there's a taper of 0.59 degrees between the two. And what have we got here? We have 4. That's perfect. We have 4 here. Now you'll find that if you measure this lad, you'll get a non-integer. That's because the integer was created here and we've just cut it away. So I'll hit escape there. We don't want that fella. But we do want the end-to-end dimension, so we'll go for this line, So we have 145. So everything is looking good there. So we will save that. Footjoint class model drawing, save. Done. So back we go, and we move on to the next step. So I'll just jump back to the, I'll close it down, so I'll just file open. So I've just jumped back to the finished article, and I just want to show you what we're going to do next. So what appears in the image is what's known as the socket. You know, this accepts the lower tenon from the lower middle joint, and it's a straightforward cylinder. So we'll do that now on the class model. I'm just going to create a circle. C for circle. And this one is to be 17.3. And we want to cut that in a distance of 20. So this is not what we expected, so something is wrong. So let's edit the feature, and I should have put in minus 20, and we want it to be a cut. You can see even if you make a mistake, you can always go back and fix it. So that's okay, so let's just take a quiet look at that. And you can see we have the inner face created now. So what we'll do now is we'll save this file. The reason I'm saving it is because I want to go and have a look at the drawing. Up comes the warning. I go up here to this little icon up here that has the triangular flash sign, and I say update the model. You can see that neatly up pops our socket. So let's just check the dimensions on the socket. 17.3, depth of 20, all looking good. Save them up, save the drawing. Now we're going to deal with the tapered bores. So there are several ways for doing this. You could put 3 circles and having done your trigonometry, put the right size at each one of 3 positions using the inner face. Here, 1 circle on that, and then put an offset plane somewhere here in the middle or beside the lower tone hole, and another circle at the opening end of the flute, and you could loft cut through. But the way I'm going to do it is I'm going to use modify, change parameters, and I'm going to create, well, I have it done here actually, a user parameter. And it's minus 0.95545 divided by 2. So that's the angle that will give you the 1 in 60 taper. And I'm going to call it taper, and I'm going to use it later on. now we'll go and we'll pick up the face, the inner face, create a sketch on it, go to make a circle, and this circle has to precisely match the end opening of the lower middle joint, and that's 13.425 in diameter. We'll finish the sketch, and let's see now. I'm going to extrude, and the direction is in, so it's going to be cut. Distance is going to be all. And we're going to set the taper angle to TA. And you see up comes the taper. And it immediately puts the tapered angle on it. And we'll hit OK. So let's just have a look at that now. You can see the taper. I'm going to save that and go back and we'll have a look at the drawing. Up comes our warning. In goes the taper. I'll just get rid of him. Now, we'll have a look at the dimensions just here. You can see the taper along the length of the head of the foot joint at 145, starting with 17.3, emerges at 11.34. And a lot of flute makers actually leave that. So it's up to you to make the choice as to whether or not you want to play around with the reverse taper. Okay, we'll save that. And back we go to the foot joint. Now, because I want to be able to control the distance up the body or up the foot joint of the reverse taper, I need to put in place the two vent holes. I'm going to do that next. And we use the X Z plane for that because we want the vent holes to be coming out facing towards the flute player, if you like. And what we do is draw two holes. Of 11 mil. I want these to sit on the x-axis, so I'm going to coincident them with the x-axis. And I want them to be a distance from the start of the foot joint. And that now that's going to be 58 and 93. So this one is going to be 58. This one is going to be 93. So we have the two holes nicely cut. Finish sketch. Now I'll just make them visible, and we will do now operation cut to extent type all. Select the two profiles. Now sometimes it's hard to figure out. Oh, it didn't pick up that. So the difficulty I was having there was picking up the second tone hole. So just pick up the sketch again, make it visible. We'll click on the first one, and the second one, it's available now. But if you have difficulty picking up the second one, there it is back again. Try Control. Just hold down the Control key and click that one also. Both of them are now highlighted. And we want this to be, I'm after forgetting now whether I should be going down or up, but it doesn't matter. If it doesn't work one way, we'll just reverse it. And we want it to be through all. Okay, so let's have a look at the front. That's where I expected to see them. They're not there. So back we go and we'll edit the feature and we will flip. There they are. So we'll save that work. And now we'll go back and look at the drawing. Update the drawing. In comes our two tone holes. Now just get rid of some of these things. It gets cluttered. And when you come to do production drawings in Fusion, you would typically have several different versions of this one drawing with a limited number of parameters on each one so that you can find stuff easily when you're in the workshop building. The first thing I want to do here is I want to check the distance between here and here and the distance between here. And as I come towards the circle, look out for the way you get the little green circle, green dot in the middle of the circle. That lets you know you're pulling up on the center of the circle. And we have 58 and 93. Is that what we wanted? That's what we wanted. So we'll save that. And we'll go back to the class model. Oh, now we're going to deal with the reverse taper. So we need to create. That's the wrong one. I want to create a sketch. And we're going to draw a circle. Now I've done some of the trigonometry for you. And if you type in a diameter 3.0748 here, we'll get a circle that will quite accurately give us the length of taper that we want. It doesn't determine the taper. That comes from the angle of the cut. This determines the final value at the open end. Now, there's no way in any workshop you'll ever achieve a 0.0001 of a millimeter accuracy on any bore. You just simply rely on the taper of your reamer, and you don't go beyond that value, because if you go beyond that value, you'll push up beyond the lower tone hole, or sorry, the lower vent hole into the body of the foot joint. So we'll accept that. We'll finish sketch, and we'll get away with the one profile here. We'll go distance all, and we'll put in the taper. Now let's see the distance goes all the way till it meets the downhill taper here, or sorry, the forward taper, but we're going to put in T, and we find taper, and now it meets the taper just there. The forward taper, the reverse taper meets the forward taper just there. Will it? Okay. We'll file save. Now we'll go and have a look at the drawing. Now, you may have noticed that a little line just popped up here in the middle of the lower vent hole. Let's get rid of that. There it sits. So that's where the two tapers meet. And now we'll have a look at the dimension of the hole here. Now it shows 13.7. Now that's not what we actually typed in, but if we double click on it, go over here, you see that the linear precision is just showing 2 decimal places. Show me what you got. That's what we typed in. So you can show it if you like. Does no harm. And we will just take a quick other dimension measurement from this line to this line. And you can see it's in the middle, or is it actually in the middle? Hit escape to stop the dimension tool, double click at 93 and say, okay, what's your precision? Well, it's 0.00003507 below the midpoint of the vent hole. Now we're going to go back and we're going to change this to something else and we'll see what happens that line. Just save that. Now, how will we change this? Sketch 8. We edit sketch. So up comes the number. We double click on the parameter. And I'm going to put in 12.8913. Enter. Finish sketch. Well, everything else remains the same. All the parameters of the cut, the tapered cut, the angle of the taper, they all stay the same. We'll check what that does to that line. Back we go to the model drawing. Up comes our warning. Refresh the drawing. You can see the way the line now has moved 98.5 away from the top of the foot joint. And we'll make one last change and see where it leaves us. We'll change that to 12.4. Finish sketch. Save it. Okay. Go home. And now let's look at the drawing. See the way this has changed also. So this reverse reaming is something that if you're making a flute, you should only do when everything else is complete and you're engaged in finally voicing the flute. So let's save everything again, and that brings us to the end of getting the timber joint ready. So the next thing we need is a component for the upper ring up at this end, and we'll call it ring 1. and we could start it on the YZ plane, and we'll hide the timber body. So C for circle, and it's to be 23 on the inside. 24.5 on the outside. Finish the sketch. We want to extrude it for 4. Now if we show the timber body, we won't hardly be able to see the ring. So we want to keep the ring activated, and we will modify physical material. And we're working in gold. Close. So we want to put in our little grooving ornaments. So we pick the XC plane, and we will wasn't zooming for me properly there just for a moment. We'll create a circle, and we'll put one here, and 0.5 is what we want, and another one there, 0.5. Now the external diameter of this thing is 24.5, so we want these little circles to be 12.25. And we want this one to be constrained to be horizontal vertical. That's that done, and we want the distance from this to this to be 1 mil. We want the distance from this one to here to be 1 mil. And that finishes our sketch. Now what we'll do is we will rotate those. Full cut. We need an axis. It's going to be the x-axis. There's our cut. Okay. So what we don't want to forget is our little fillet. So we want to go to fillet. Pick up both sides. 2 edges selected. And 0.25. Does it nicely. And I think that's us done with that ring, so we'll save the work. Now I leave you guys to actually do the ring on the other side. We've done so many rings at this stage, and this is a good example for you as to how to proceed. Just simply start with this face, generate your 23 mil circle, and proceed from there. Make sure you set it up as another component. Okay, have fun. In our next session, session 14, we're going to actually assemble the entire flute and make sure that everything is in good working order. Okay, thank you. Talk soon.